Hi class, this is section 5.1, Properties of Exponents, and our notes this chapter are going to look a little different. We're doing them with frames. So Properties of Exponents is about the rules, for simplifying, expressions, with exponents. So there's a bunch of different rules that we'll talk about in this first lesson, but it's okay. These rules were all things that you were introduced to in Algebra 1B, so this should sound very familiar. That's why we're covering so much in just one lesson. So let's first talk about the product rules, and I'm going to make this a little bit bigger so I can see it and write a little bit easier. So here's my first main idea, the product rules, and you have some stuff written in yours that is not on mine, so I'll have to add them in there. So first of all, product of powers. So our product of powers tells us this. If I have a number a to a power m times a number a, it's a times sign, times a number a to a power n, that equals a to the m plus n power. So a to the power m times a to the power n equals a to the m plus n. So what you have to remember is when you're multiplying, we're going to add our exponents. So when you're multiplying, we're going to add our exponents. So here's our first example, and you've got this written on your page already, so I'll write in black what you already have written. You have b to the negative 4 times b to the 7 times b to the 6 equals, and if you apply our rule that we just talked about, you're going to add our exponents. So that equals b to the negative 4 plus 7 plus 6. So if we add negative 4 plus 7 plus 6, that's b to the 9th power. And we add them together, and this is our simplified power. So just add negative 4 plus 7 plus 6. Our example 2 here, you've again already got some on your paper. You've got negative 5 times negative 5 to the 3rd power. So what you have to remember, if there's no power written, then we've got a power of 1 there. So you can put that power of 1 in. So this is negative 5 to the 1 plus 3 power. And if you simplify that, that's negative 5 to the 1 plus 3 is 4. So negative 5 to the 4th power. And that's our simplified form. The next one is scientific notation. So again, you've gotten this problem written down, 4.5 times 10 to the 3rd. The quantity, so we've got parentheses, times the quantity 3.7 times 10 to the negative 1st equals. So you've gotten this down already on your paper. So what we need to do is first combine our numbers, 4.5 times 3.7. That'll give us 16.65 if you multiply them together. Now we're going to combine our powers, so that's times 10 to the, and if you add your exponents, since we're multiplying, 3 plus negative 1 is 2. But what I want you to notice here, this is not in scientific notation. Scientific notation, I can only have one number right here. I only have one number in front of the decimal. So I need to take this decimal and move it over to this spot. So if I do that, I have 1.665 times 10 to the, and here's how I remember it. My number, 1.665, got smaller, so my exponent needs to get one bigger to make up for that. So times 10 to the positive 3. So there's our product of powers property. Let's now look at the power of power properties. And these are our power rules. They're in our power rules column. So our first one, our power of a power property, tells us that the quantity a to the m, so you need to be writing this, and that raised to the n power, that equals a to the m times n. So when they're right next to each other, you have a power raised to a power, you multiply the two exponents. So let's write that out. If you raise an exponent, so I'll put exp for exponent, to an exponent, you're going to multiply. Whoa, that was a crazy line right there. Let me fix that. So we're going to multiply if we raise a power to a power. I don't think we need to see that, do we? So here's my m times n. So we're going to multiply. The next is the power of a product property. So a product means two things that are multiplied. So I've got a times b to the m power. And what that tells us, if I have two things that are inside parentheses with a power outside of it, I can give that power to both things on the inside. It's kind of like distributing. So it's a to the m times b to the m. And a lot of students remember this as distribute. So I'm going to put distribute, but I'm going to put these around it. Distribute. Because we're kind of distributing our exponent to everything. So what we're doing when we have a power of a product. Next, we have the power of a quotient. So a quotient is two things that are divided. If I have a divided by b, and that's raised to a power, I simplifying it by giving my power to both the top and bottom. So that equals a to the m over b to the m. So again, it's kind of like distributing. So I'll put distribute again. So because we're kind of distributing, we're going to distribute our exponent to everything. And our examples here, you've got two examples written. We're just going to start with the first one that you have written. So your first example is the quantity 4 times m squared times n to the third. And that whole quantity is raised to the 4th power. So we want to simplify this. And in order to do that, we're going to have to use a couple of different rules. So the first rule that we're going to use is our power of a product, where we give that exponent of 4 to everything. So I'm going to give this 4 to that 4, I'm going to give this 4 to the m squared, and I'm going to give the 4 to the 3. So 4 to the 4th power, well, that's 256. M squared to the 4th power. Well, if we look at our property up here, if I've got m squared to the 4th power, we're going to follow this property right here. And that tells us if we've got a power with another power, then we multiply them. So m to the second and then raised to the fourth again. 2 times 4 is 8. So this will be times m to the 8th power. And then if I have n to the third raised to the fourth, again, this is this same property, and we multiply them together. So 3 times 4 is 12. So that would give you n to the 12th. So we've got 256, m to the 8th, n to the 12th. Now before I do the second example, I'm going to move my screen over just a little bit because I want to talk about the quotient of a power property before we do our example 2 here. So our quotient of a power property, this one tells us if you have two powers, so a to the m over a to the n. Now the key here is those have the exact same bases. Your top has a base of a and your bottom has a base of a. In order to simplify that, you're going to do a to the m minus n. This is how we reduce it when we've got the same base with different exponents. So when we're dividing, you need to remember to subtract your exponents. So let's go back and look at this second example that you have at the bottom of the page. So number 2 down here at the bottom, it's already written in yours, that's why I'm writing in black. So it's 2x to the third times y over 4y squared times z. And then you've got that whole quantity raised to the third power. So what we have to remember to do here is a couple of things. We've got a few rules that we could apply, and what makes these rules kind of tricky or confusing to some students is it really doesn't always matter what order you apply the rules in, as long as you apply them correctly. So I think I somehow erased part of my 12 up here. Okay, so as long as we apply them correctly, we'll do okay. So I'm going to give this 3. I'm going to first get rid of my parentheses, and I'm going to do that by giving this 3 to absolutely every single piece. So I have to give this 3 to every piece on the top and the bottom. So I've got 2 to the third, which is 8. I've got x to the third again. So x to the third again. I'm going to multiply those 3's. 3 times 3 is 9. That gives me x to the 9th power. And then I've got y to the third power. Because really it's y to the first. 1 times 3 is 3. Over 4 to the third, which is 64. And then I've got y to the y to the second to the third power. So y to the second to the third, that's y to the 6th. And then still on the bottom, I've got z, and I need to give that the third power. So I've got z to the third power on the bottom. So now notice I've got some things that I can reduce still. So if I want to reduce these, which I do, okay, to reduce these, I'm going to reduce my 8 over 64. And 8 goes into both of those, so it reduces to 1 over 8. So I'm going to keep that 1 out of the top, and I'm just going to put the 8 in the bottom. So I'll erase this extra right here so you don't get confused. I'll try to. I guess I can't. But I put that 8 in the bottom for you right there. Okay. Now we're going to look. This x to the 9th right here does not have any other x's, so that x to the 9th must stay on the top. Got y to the third over y to the 6th. So we're going to apply this property right here where if I've got the same bases with different exponents, I just subtract them. If I'm dividing same bases, I just subtract my exponent. So I'm going to say 3 minus 6. 3 minus 6 is negative 3. So because that's a negative 3, I need to put that y on the bottom with a power of positive 3. Okay, and we haven't gotten quite to that one yet. We will in just a minute here. But if it was y to the negative 3, it goes on the bottom with a positive exponent. And then I've got z to the third on the bottom still. So this z to the third stays right here on the bottom. And this is my simplified form. Okay, let's look at our example 1 for the quotient of a power property. So you have written on your page already 11 to the 8th over 11 to the 5th equals, and as we said above, you're going to subtract your exponent, so it's 11 to the 8 minus 5, which is 11 to the 3rd power. For example 2, we have 16 times m to the 4th times n to the negative 5th power over 2 times n to the negative 7 power. So let's reduce this. 16 over 2 is just a plain 8, and that would go on the top. So if this is my fraction bar, that plain 8 would go on the top. M to the 4th doesn't have anything to reduce it, so I'm going to keep m to the 4 on the top. And then these, if I subtract my exponents, that's n to the negative 5th minus a negative 7. Minus a negative becomes plus, so it's really n to the 2nd. And so it's n to the positive 2, it'll go on top. And I don't have anything in the bottom, so it's just this right here. Here's my answer. Let's do a scientific notation problem like this, and you've already got one on your paper. I'll write it on mine. It's 1.8 times 10 to the negative 3 over 4.7 times 10 to the negative 5th. Okay, so to reduce this, we're going to reduce up and down again. Oops, I just threw my pen. So we're going to reduce this, 1.8 divided by 4.7, and that's 0.383. Then we're going to have times 10 to the, we need to subtract our exponents. Negative 3 minus a negative 5 is positive 2. But looking at this, it's not in scientific notation. It's not in scientific notation because I have a 0 in front of the decimal. I need to at least move my decimal over one spot. So that would be 3.83. And my number got bigger. 3.83 is bigger, so my exponent needs to get smaller by 1. So it's times 10 to the 1st. Or, because it's only 10 to the 1st, really, that's just 38.3. You might not use scientific notation when it's such a small number. You could have either one of those answers. All right, I'm going to move my frame over a little bit again here. Now let's talk a little bit more about our negative exponents. So our rule for negative exponents tells us if I have a number to a negative exponent, I'm going to make that 1 over that same number to the positive exponent. And what I really do is switch the sign. So or switch the side of the fraction. So for a negative exponent, we're going to make the reciprocal. And you know, because we've talked about reciprocals, a reciprocal, you flip the top and the bottom. So that's what we're really doing. The next one, 0 exponents, this is our simplest one. It says a to the 0th equals 1. So that's anything to the 0 power is 1. So anything at all to 0 power equals 1. Anything. Have I said anything yet? All right, so you have a problem on your paper. You have 14 m to the 3rd, n to the 5th. the quantity, so parentheses, over 7m squared p. And this is all raised to the 0th power. So, as we said just above here, anything to the 0 power equals 1. So this is anything, and it's got a power of 0. So because it's anything and it's got a power of 0, it just equals 1. It's that easy. Anything at all to the 0 power is 1. We've got one more example here. So I've got c over d to the negative 4th. And that raised to the negative 2nd power. So let's simplify this. So to simplify this, I'm going to first get rid of that negative exponent. So to get rid of that negative 2, I just want to get rid of the negative sign. I'm going to flip my top and the bottom. So I'm going to say d to the negative 4th over c. And that would now leave me with an exponent of positive 2 since I flipped the top and bottom. Now we know if we have the power of a quotient, we can give that exponent to both of the things on the inside. So this becomes 9 to the, if I do not 9, d to the negative 4th and square it, well, negative 4 times 2 is negative 8. Over c to the, give it the 2nd power, it's just c squared. But this isn't simplified because I've got a negative exponent. In order to get rid of that negative exponent, I need to change the side of the fraction that it's on. Now, a common mistake that students would make here is they would try and flip the c squared and the d to the 8th. That c squared, though, does not have a negative exponent, so c squared has to stay right where it's at. We're only going to move the d to the 8th power to the bottom. Now, we don't have anything in the top, so we've got to put a 1 there to hold its spot. And this is my simplified answer. So the last thing we have to do here is fill in our so what statement. Okay, our so what. What's important to understand about this? So the so what, what's important to understand about this is when you're simplifying exponent, there's many rules. So when simplifying exponents, there are many rules we apply to the exponents. Whoops. Didn't mean to move that. To the exponents. We don't apply them to the base, we keep the base the same. So there's many rules that we apply to the exponents. We keep the bases the same. And another thing to remember is these will be used in Chapter 6 too. So since we're going to use them more than just this one time, you have to make sure you learn them. And these are basic rules of exponents that you can use anytime you're using exponents. So it'll be very likely that you see them again. So this is the end of the lesson. Make sure if you have any questions, you star them so we can talk about them in class tomorrow. Have a great day.